Okay, so here's the solution to problem number one. I told you you would need some implicit differentiation, so I'll show you where that pops up here. But we have a right triangle whose legs are 27 inches, so I'll label that as 27. The other leg is 36 inches. We got that. And the sides are changing. So although we can't see it happening, we know that the sides are changing. The short leg is decreasing by 2 inches per second. So there's a rate, 2 inches per second. Now I got to label this. So I'm going to label this as A. I'm going to label the short leg as A. I'll label the longer leg as B. So we know that dA dt is 2 inches per second. And it's decreasing, so it's going to be negative because it's decreasing. The longer leg is growing, dB dt, at a rate of 8 inches per second, so that's positive, 8 inches per second. Now, what they want to know is what is the rate of change of the hypotenuse. So let's just label the hypotenuse as c. So they want us to find dc dt. So I need to come up with a formula that relates a, b, and c. Well, the formula is going to be since it's a right triangle, the formula is going to be the Pythagorean theorem. So I can say that a squared plus b squared is equal to c squared. And if I want to find dc dt, then I'm going to have to take the derivative of both sides of this equation with respect to t, dt of c squared. So this is where the implicit differentiation comes in. So when I take the derivative of a squared, that's going to be 2a, but I need to account for the dA dt. There's your implicit differentiation. When I take the derivative of b squared, that's going to be 2b times the derivative dB dt. And then when I take the derivative of c squared, that's going to be 2c dc dt. All right, and we have just about all the information we need. So let's start plugging in and see where this takes us. So 2 times the a value, which is 27, times dA dt, which is negative 2, plus 2 times the b value, which is 36, times dB dt, which is 8, equals 2 times the c value. Oops, I don't have a c value. Right now it's labeled as c. So I got to do a little work off on the side. I got to do some scratch work. In order to find c at the moment, right, when the legs are 27 inches and 36 inches, I can take 27 squared plus 36 squared to equal c squared. And then I'm just going to solve this for c. So I'll add those together, take the square root, and I end up getting c to equal 45 inches. So that's going to be a 45. Now, at the moment, you didn't realize that you would need this c, but as I look at my equation, if I want to solve for dc dt, then I need to have a value for all the other numbers here. So now the rest of this is just algebra. Negative 108 plus 576, which is going to be 468, is equal to 90 dc dt. When I divide both sides by 90, I get dc dt to equal 5.2 inches. Is it inches? Is it meters? It's inches. Whoops. Inches per second. So I can say that dc dt, or I can say that the hypotenuse is changing at a rate of 5.2 inches per second, and that's the solution. How did you do?